All right, good morning, eighth graders. So today we're going to be learning about how graphing systems of equations inequalities work. So we've worked with graphing systems of equations and we've worked with graphing inequalities, but now we're going to be working with graphing systems of inequalities. So let's kind of dive into this. And so graphing method, and so example, graph the inequalities on the same plane. So x plus y is less than or equal to 6, and 2x minus y is greater than 4. And so the first thing we have to do is before we can graph them simultaneously, let's look at them separately. And so let's just look at x plus y is less than or equal to 6 first. And so if we were to graph that and put it into y equals mx plus b form, we would have a plus 6 and then down 1 over 1, down 1 over 1 for our slope. And so we're going to get a graph like this. Now, if we're trying to graph both of them, let's look at what happens when we graph the 2x minus y is greater than 4. We're going to get something like that, right? And because when we divide by, or when we set this up into y equals mx plus b form, you're going to change that sign, which means we're going to shade everything below, and we're going to have a negative 4. And so now that we have our two graphs, so what do we think is going to happen when we graph both of these inequalities on the same coordinate plane simultaneously? And so what's going to happen is that we are going to get something like this, right? The green is our first inequality that we graphed, and then the red is the second inequality that we graphed. And so the solution to our two inequalities is the brown area. And so it's kind of where the two inequalities collide. This is when both statements become true, and that's the shaded region where both colors are together and mixed, and that's considered the brown area. And that's all we're doing differently here. We're just shading and looking for that collided area where both colors are meeting, and that's your answer for a system of inequalities. So the green region and red region are outside the solution set, okay? So any of the green, any of the white, or any of the red are not solutions, but any of the brown area are solutions to our two inequalities. What are the steps? Let's look through these steps. So first you want to graph the first inequality. Shade lightly or use colored pencils. So I highly recommend you start bringing colored pencils because it's going to be very beneficial to kind of look at when you're using two different colors. You're going to then graph the second inequality and shade lightly using a different colored pencil. Shade darkly over the common region of the intersection, and that is your solution. And that's all there is to it. So graphing systems of inequalities. So again, more in-depth steps, you're going to write the inequalities in slope-intercept form, use the slope and the y-intercept to plot the lines, draw in the lines using a solid line or less than or equal to or greater than or equal to, use a dashed line for less than or greater than. You're going to pick a point above the line or below the line, test the point in the inequality. If it makes the inequality true, then shade the region that it contains that point. If the point makes the inequality false, shade the region on the other side of that line. That's another way to think about when to shade. Or you can also remember that if it's greater than or equal to, shade above, less than or equal to, shade below. Systems of inequalities, you're going to follow these 4 steps in each inequality over the region where the solutions to the inequalities would overlap, and that is your answer, okay? And so here's an example where y is greater than or equal to 2x minus 4, y is less than negative 3x plus 2. And so again, we're going to kind of graph our two inequalities, right? And put our first line, the dark or the blue line there is our first equation. We're going to kind of test it just to make sure it's true. 0.00 shows that it is a true statement, so we're going to go ahead and shade above. And then we are going to go ahead and graph that second equation. It's going to be a dotted line because it's a less than sign. And because it's less than, we are actually going to shade everything below, or you can pick a point. That works as well. But I highly recommend you just remember that less than, you're going to shade below. And so now we are looking at this combined area where both solutions collide. And that's going to be right here. And that is our answer. Again, you could try this at home if you would like. I'm not going to make you do it right now if you're watching this video at home. You could also try this one. Let's go ahead and look through this. We plot our first line. We're going to shade above, and it's going to be dotted because it's greater than. We can go ahead and graph our second line, our second inequality. It's going to be a dashed line as well, and we're going to shade above because it's also greater than. And then this dark blue area is our solution, right? It's where our shaded areas are colliding at the same time.